Okay guys, so in the last video you have learned about the section modulus, how to calculate section modulus for different section, and you have also got the basic idea how to choose a particular section for designing your beam. Okay, and also you have learned if you are asked or if you are given a particular section area A, in that case in between a square section and a circular section, which one is more economical. Of course, if you have watched my video, in that case you know that the square section is more economical compared to this circular one. Okay, and also you have a clear idea about how the stress are distributed with respect to the neutral axis. Okay, if this is the neutral axis, you know that the stress distribution is something like this. Okay, this varies linearly. Okay, like this, and this top one is in compression and the bottom one is in tension, in case if you have a bending moment applied like this. Okay, a positive bending moment, correct? So in the last video I have promised that I need to take at least 10 minutes to discuss how the I section has bound. Okay, what is the basic theory behind this I section? Okay, so before starting, just I would like to draw your attention. Here you can see that the square section here is more economical compared to the circular one. Okay, and also here you can see that in this stress distribution, the maximum stress are distributed away from the neutral axis. Okay, so here you can see that the maximum stress are accumulated here. Okay, and also simultaneously, if you watch the square section closely, here you can see that the material which are away from this neutral axis, this is the neutral axis. Okay, the material away from the neutral axis is more compared to the material away from the neutral axis in case of circular section. In case of circular section, here you can see how much material are accumulated away from the neutral axis, but in case of the circular square section, you can see that the material is much more compared to the circular one. So we can also conclude that the more the material is distributed away from the neutral axis, okay, it is utilized more economically. Why? Because in the stress distribution you can see that the maximum stress are distributed away from this neutral axis. Okay, so ideally if we had a situation that we are allowed to put all the material away from the neutral axis, let's say this is the neutral axis. Okay, and you have given total cross-sectional area A just like this one in case of a square or circle, and now you are allowed to put all the material away from the neutral axis. So what would you do? You would simply put all the material away from the neutral axis. Got it? So this is the hub material, that is A by 2 area, and this is A by 2. Okay, and of course the distance between them is h. So the distance from the neutral axis is coming as h by 2, and here is also this is h by 2. So in this case, what is the section modulus? Okay, what is the section modulus? So if you calculate the I is coming as 2 times area times distance square, AR square, the basic formula for I, and you are getting I as, this is coming as cancel 2, it is coming as A h square by 4, and Y max. Okay, I am just calculating Z. If you are not familiar how to calculate Z, please go to the previous one so that you can understand this in a better way. Okay, so Y max is here h by 2. So we have Z for this ideal condition is coming as A h square by 4 by h by 2, which gives us A h by 2. Okay, so this is the ideal case where the section can be most economical for any given cross-sectional area. Okay, so practically you cannot make any section like this one. Okay, just you have this part and you have this part. How you can hold this to one? So you have to put at least some material in between these two flanges. Okay, we are using the technical terms flanges. Okay, so these two flanges need to be connected by using some material, and this material is known as web material. Okay, this is the web material. Got it? So you may not get this exact section modulus for this section now. Of course, the section modulus for this section, we call this I section, is less than this one. Okay, but it is compared to the square or the circular one, of course it is higher. And if you observe the section modulus for different I section, there you can see that it is more or less near about 1/3 of your A times H. Okay, and this is the reason why in maximum cases for designing beam we use our I section. Okay, so this is the story behind I section. So before closing this video, I just I just would like to check whether this is actually correct or not with some real data. Okay, so let's go to some section here. Okay, here we have taken, you can see this is ISMB 300. Okay, ISMB 300, and it has a sectional area 56.26 and height H is 30 centimeter. Okay, so if we simply put the value here, we are getting that 56.26 area, okay, times the height 30 divided by 3, because in our formula we have used 3 as denominator. Okay, and we are getting the value for section modulus as 562.6. okay, and now let's check what is the actual section modulus for I section. Here you can see that section modulus is 573. Of course, we are considering everything about this x-axis. The neutral axis here is x-axis. Okay, so we are getting here 573.6. okay, and as per our calculation it is coming as 562. So we are almost close. Okay, so this is the reason why I section are used widely as beam section. I hope you have got a very basic idea behind this I section concept. Okay, and for now, yeah, that's it.